Today, we're going to be talking about the strongest solar flare that has happened in this cycle. And, who knows, maybe there'll be a strong one, but this is the most strongest one we currently have. So we'll be talking about that. In the Sky Report, we're going to be talking about the first quarter moon. That is kind of the big event. I believe that is this Friday, but that's something I'll delve down later. And it has happened exactly 1 week after the full moon that happened last week. And finally, we're going to be talking about NASA's DART mission to the asteroids in 2022 and how that was followed up with the launch of the European Space Agency's Hera Mission that occurred this Monday. But anyways, all that more will be discussed. This is Interstellar Insights. Alrighty, so starting off, we're revisiting a very familiar topic. I think we've been covering, there's at least been 2 or 3 episodes where we've been talking about the sun. But we talked about it, I believe, in the first episode of this podcast all the way back in June, and I think we talked about it quite a bit in July. But now it's October, beginning of October, start of fall, and we are still discussing about the sun. So before we get in, kind of a refresher. So right now we're in a solar cycle. We're approaching the solar maximum, which is essentially when the sun is going to be very frequent and buzzing with solar flares across its surface. So that's expected to happen in 2026. Before the frequency and strength of these solar flares dives back down for I don't know how long, but essentially once it reaches a certain point, which is called the solar minimum, where there are not that many when there are not that many solar flares, and the solar flares that do happen are very weak. That is the solar minimum before the 11-year solar cycle starts up. So yeah, that's a basic reminder of the sun and solar cycles. But anyways, this happened very recently, but the sun has released its strongest solar flare this cycle last Thursday. So the strongest so far. There's probably going to be stronger ones coming our way, man. Excuse my throat's kind of irritating me. But like I said, strongest solar flare, there might be, more stronger ones coming along the way, especially as we approach the maximum, which is in 2026, like I said. But like this solar cycle, it's not that big. It's only going to give aurora. They only gave an aurora light show over the weekend, and it's not going to be as big as the one in 1988 or 1989 that gave a regional blackout in Quebec, or the Carrington event of 1859, which actually we should talk about because that's kind of big in terms of the sun. So the Carrington event of 1859 was basically the strongest solar flare ever recorded during solar cycle 10. Sorry, I'm struggling with words today. But and just a reminder about the solar cycle system. We've been recording solar cycles since 1755, and they're 11-year periods. So this one that occurred kind of at the turn of the 1860s, if you will, is solar cycle 10. And of course, right now we are in solar cycle 25. But anyways, the Carrington event basically led to lots of aurora borealis. You usually think of aurora borealis in terms of the poles, but you could see aurora borealis everywhere, or the lights basically everywhere, any point on Earth. That's how strong it was. And it was so it induced so much current on Earth that telegrams, or not telegrams, telegraphs, telegraphs, Morse code stuff. There were telegraph failures everywhere, because that's what they used to communicate back then. And it even actually allowed for some places to not even use batteries to power their telegraphs because of the current. And so some people were able to just communicate with each other without batteries, so they're just basically using the solar flare as a means of power now. This happened in 1859, before there was a real electric infrastructure. That was before, if you look at history, the Second Industrial Revolution, and where Nikola Tesla discovers alternating current, and we get a big power infrastructure. So who knows what the Carrington event would have looked like if it happened today, where we're so dependent on electricity. But yeah. And anyways, going about that, we're talking about the strength of this solar flare. So in order to understand that, we have to understand the scale that they're using. It's called the X scale. And basically, the strength, basically, like each number up is essentially double the previous number. So give you an example. Let's say a solar flare happened and it had a rating of X2. Basically, what that means is that the amount of X-rays that get released by the solar flare are double the amount that are in X1, but the amount of X-rays released in an X2 solar flare are half as much as the X-rays released in an X3 solar flare. So to give you, to give you kind of an idea, this solar flare was rated at an X9. So essentially, if you were thinking of it mathematically, really the amount of X-rays that were in the nights that were released are basically like the amount, or basically like 2 to the 9th times the amount of X-rays that get released per solar flare. Does that math sound right? I mean, I guess it's more like 2 to 10th. I don't know. Don't take my word on that math. That math is I'd have to take a deeper dive. But essentially, it's just doubled up, basically. Kind of based off powers of 2, essentially. But compared to the Carrington event, that was estimated to have a power of X45. That was an X45 solar flare, so it was very powerful. So yeah, basically nothing really happened this solar flare, just some aurora in the night sky, the lights. But as we approach this solar maximum, it's only going to get stronger and stuff. So we should see, more solar flares more frequently, and solar flares that are more stronger, and they're going to bombard Earth with photons and X-rays into the magnetosphere of Earth and stuff. So yeah, if there's another big event like this, we're definitely going to cover it on this show. But anyways, for the third or fourth time of this podcast ever, I'm going to stop talking about the sun, and now let's go move over to the Sky Report. Alright guys, so moving into this week's Sky Report, reminder, oh my god, I'm coughing way too much. Reminder, this is the first time I'm going to say this in a long time, but a reminder that all the times that we talk about are going to be on Eastern Daylight Time. This show is a very East Coast centric one, so all times are in Eastern Daylight, so I don't care if you live in Chicago, do the math, whatever, blah, blah, blah. But anyways, starting off with today, Wednesday the 9th. Nothing really happening tonight, but a lot of stuff happened this morning, which I'll just briefly cover. So Jupiter was up, and it was stationary at around 3 a.m. this morning, and it stopped in the sky 4 degrees west of Zeta Tauri, with some of its moons like Europa and Callisto hanging eastish of Jupiter, and Ganymede was hanging out by Jupiter's northwestern limb, kind of popping over there, and then Io was popping over Jupiter's northeastern limb during the night sky around this time at 3 a.m. So yeah, nothing really happened in the night sky, but it's just a lot of morning stuff. But anyways, for October the 10th, we get our first quarter moon. So first quarter moon is going to occur at 2:55 p.m. And then most of the moon is going to appear half lit, and various surface features are going to be present, such as Montes Alps, basically a large moon valley that you can see at that time, and then and Hipparchus, which is a large shallow crater on the moon. So nothing happening that night. It's really just this first quarter moon that is very important, although to be fair, 2:55 p.m. on the East Coast is the afternoon, so the sun's going out, so I don't know how you can really see it. Maybe if you live in Asia, Central, something like that, India maybe, and it's nighttime there, probably could see the first quarter moon there. But anyways, yeah, that's all I've really got for Thursday. But anyways, Friday, October the 11th, Pluto is going to be standing stationary in the night sky at 10 p.m. In the constellation of... Actually, no, it's not in the constellation, the constellation of Capricornus is going to be... Yeah, I guess... Wait, hold up. Yeah, no. Pluto is in Capricornus, but you can find Capricornus by looking not far east of the waxing gibbous moon. But anyways, if we turn towards the eastern horizon in the night sky, the constellation Perseus will be more than 30 degrees high in the sky by 10 p.m. At night, so that'll be up there. And then there's also going to be Cassiopeia, and near the border of, like, between Cassiopeia's and Perseius's northwestern border in terms of the constellation, there's going to be a double star cluster there. And they're classified as H and Chi Persei. So, like, or not Chi, like the Greek letter Chi, but those are going to be H and Chi Persei clusters. But their actual names are, and in typical astronomical fashion, they're going to be poorly named, NGC 369 and NGC 884 respectively. So yeah, double star clusters, poorly named, not good stuff. Not good stuff. But anyways, besides that, let's go into some times. I'm going to say it again for the second time. All these times are in Eastern Daylight Time. So, if you don't live on the East Coast, once again, we're an East Coast centric show. So if you live out in Chicago, figure it out, or, wherever you live. But anyways, today the 9th, sunset's going to occur at 6:28 p.m. Moonrise is going to be at 1:57 p.m. and moonset's going to be at 10:38 p.m. And sunrise on October the 10th, so that is tomorrow, Thursday. Sunrise is going to occur at 7:06 a.m. Sunset is going to occur at 6:27 p.m. Moonrise is going to occur at 2:47 p.m. and moonset is going to occur at 11:44 p.m. On Friday, we have a sunrise at 7:07 a.m. Sunset at 6:25 p.m. Moonrise at 3:59 p.m. and moonset that occurs Saturday. I don't have the exact data for Saturday, which is why we only do a 3-day sky forecast, if you will. But anyways, the phases of the moon for October 9th and October 10th are going to be waxing crescent, while on the 11th, because of the first quarter moon, it will have changed to a waxing gibbous. So yeah, that is this week's Sky Report. Let's go move on to the second big story / topic of the day. Alrighty guys, so our last big topic of the day is going to be about a mission done by the European Space Agency, otherwise known as the ESA. That is the Hera mission. But before we talk about that, we're going to be talking about NASA's Double Asteroid Redirection Test, otherwise known as DART. So, because Hera is a follow-up to DART, so we first have to talk about DART in order to really understand the purpose of Hera and the mission goals of Hera. But anyways, in 2022, NASA launched the DART mission, basically, and it was able to successfully slam into an asteroid. It's not really an asteroid, but essentially an asteroid-like object, more like a moonlet because of how small it is, but dimorphous. And by slamming successfully, like it didn't miss, by successfully slamming in the dimorphous, they were able to prove that, by such impacts can change the trajectory of large space rocks. Now, I don't have enough context. It really doesn't have context of whether this asteroid was like one of those doomsday asteroids that could potentially hit Earth, or if there's just a close nearby asteroid for this potential experiment to see if there were an asteroid that could potentially extinct majority of life and humanity on Earth, if we can try and prevent that by slamming into it, deflecting it, and making it go off course away from Earth. But yeah, it seems that they have proven that. But anyways, here we are 2 years later in October, and there is now a new mission by the ESA. It's kind of a continuation of NASA's DART mission. But anyways, Hera, that the goal of that mission is essentially to go back to dimorphous and essentially see how that small local asteroid system has been impacted. Because while we do know that Dimorphos has, or not Dimorphos, Dart, see, they both start with D, I'm getting confused. Since we know that Dart obviously had a great impact on Dimorphos, we're essentially going back in to measure how impactful that was and to the small asteroid system that it's in. But anyways, it actually just launched just this Monday, 10:52 a.m. Eastern Daylight Time. It launched from the Kennedy Space Center in Florida. So yeah, and then like I said, it's heading back to, well, actually it's not heading back to Dimorphos, but it's heading to another asteroid within the system to see if that asteroid was potentially impacted. It's heading to oh my god, oh my god, here. There's like a bunch of numbers in this name, like unnecessary. It's called 65803 Didymos. They should just call it like Didymos instead of adding the 65803. Right, this is really like 65,803 Didymos. I don't know, but I'm getting a little bit off topic. It's going to reach Didymos in late 2026, and like I said, that asteroid is in the local system with Dimorphos, and it's going to observe the impact of Dart on Dimorphos. See if something else has happened to Didymos, or if it just impacted Dimorphos. Dimorphos's trajectory in the solar system. But anyways, this we won't expect results till late 2026. So 2 years ahead of now. Probably I would have graduated out of high school. It's going to be in late 2026, so it'll be like first year of uni for me, university. But Hera is expected to reach Mars and Deimos. It's one of Mars's two moons besides Phobos in March of 2025. And then also the launch on Monday, like I said, Kennedy Space Center, but it was also done with a Falcon 9 rocket courtesy of SpaceX. Yeah. So, yeah, pretty interesting stuff, stuff like this, you got to protect humanity, got to protect life. Very important for that. So, yeah, this is a semi big deal, especially, when it comes to defending Earth from doomsday asteroids that could potentially end life on Earth. So, yeah, pretty interesting stuff, pretty cool. But anyways, let's go move on to this week's edition of Astronomy Trivia. Alright guys, so welcome to this week's edition of Astronomy Trivia. Before we get on to this week's question, what that question is, let's talk about last week's question. So I believe that question was, what space probe landed on Mars between the Spirit... excuse me, I just yawned weirdly. Between the Spirit and Opportunity rovers in, I believe, 2004, 2005, and the Curiosity rover in 2012. I believe that was the question. What landed on Mars that was not a rover, but a space probe, that was essential. And the answer to that question is going to be NASA's Phoenix spacecraft. So essentially, Phoenix was built and designed to study the history of water on Mars, as well as check for habitability if Mars could ever and if has supported life on that planet. But anyways, this operated from about May to November 2008, which is between 2004 and 2012. I believe Spirit and Opportunity was 2004. It's either between 2004 and 2006. I'm pretty confident that Spirit and Opportunity happened in 2004. But anyways, Phoenix was sent and landed in about Mars's North Pole, I believe, where it discovered water at the poles, except that the water on Mars is in the form of permafrost. Kind of like this frost that is on the North Pole of Mars. It's just in there. But, of course, there is no life because besides the need for water, Mars's atmosphere isn't really good at dealing with solar radiation that is emitted from the sun, because we on Earth we actually have an atmosphere that can protect us in a pretty strong magnetic field and a magnetosphere that can protect us from those dangerous X-rays that come. But Mars does not have that, so even though they got water, they really can't support life because of that, because life would get kind of cut down by the solar radiation. But yeah, that's all Phoenix is, trying to see if Mars is habitable. So anyways, let's get into this week's question for astronomy trivia. Who believed Earth was at the center of the universe? I'm going to say this again. Who believed Earth was at the center of the universe? All right, I'm going to make a poll on YouTube and Spotify for both of their respective listeners for those platforms, and you guys can answer there of your opinion of who believed Earth was at the center of the universe. But anyways, let's close out this week's episode. All right, guys. So this wraps up this week's edition of Interstellar Insights. Next week, it's going to be regular song and dance in terms of this podcast. I'm going to try and have someone interviewed probably this Saturday or Sunday. At the time, this is posted Wednesday. So probably Saturday or Sunday, I'm going to try and get a bonus interview in, but I plan on not releasing that till next Friday. Hopefully, that's the plan. So essentially, I'm going to try and expand the bonus content, just like a little extra content to keep you guys not bored, because I know this can get kind of dry a little bit. But we're going to try and I'm just going to interview people I know that are interested, and we're going to talk about stuff that's not astronomy. That's probably going to be the description of the bonus stuff, is stuff that's not astronomy. But we'll try and do that. And then what my plan is that for those interviews, they're going to get posted every Friday at 12 p.m. Eastern time, just like my regular show. At that same time of day, just instead of having it both at the same time, just separate them so that way one show doesn't overpower the other, and you can have moments with both of those shows. So that's all I've got. If you've liked this episode, feel free to give me a like and follow or subscribe me, depending on if you're listening to YouTube or Spotify. And once again, it does really mean a lot to me, because if we can get a significant following, we can make this podcast better. We can improve the quality. We can make more segments. Make this time a little bit more meaningful. But anyways, that's all I've got. This is Michael signing off.